Do you know some fascinating facts about the universe? What if we tell you? Well, today we are going to. Here we begin. There is no such thing as the center of the universe. No, the Earth is not the focal point of the universe. It's not even the galactic nucleus. So no, our galaxy is not the entire universe, nor is it its center. Don't get your hopes up, but the universe has no center. Each galaxy is moving away from the others. Everything, down to the atoms, would be ripped apart. This notion arose as a result of the observed accelerated rate of expansion. Scientists who supported this radically catastrophic conclusion believe that this type of expansion would continue indefinitely, forcing everything to be ripped apart. Its members are eager to get as far away from one another as possible. The galaxies of the members we're discussing, as previously stated, they are moving away from each other at an increasing rate. In fact, prior to the discovery of the most recent data, it was thought that the universe would end in a big rip. The majority of matter in the universe has repellent gravity. In the aftermath of the Big Bang, the universe's constituent galaxies are flying apart like cosmic shrapnel. Gravity, which acts like an elastic web between the galaxies, should be the only force at work. Contrary to popular belief, astronomers discovered in 1998 that the universe's expansion is accelerating. To explain it, they proposed the existence of an invisible substance, dubbed dark energy, that fills space and has repellent gravity. The repulsive gravity of this dark energy is hastening cosmic expansion. Dark energy accounts for nearly 2/3 of the universe's mass energy. As a result, school science is behind the times in proclaiming that gravity stinks. It's blowing in most of the universe. Although the Earth is not flat, the universe is. According to Einstein's theory of general relativity, the universe can take 3 different shapes: open, closed, and flat. WMAP measurements on the CMBR have revealed yet another confirmation that the universe is flat. Combining this geometry with the concept of an invisible entity known as dark energy corresponds with our universe's widely accepted ultimate fate, which, as previously stated, is a big freeze. The universe has a radius of more than 150 billion light-years. Current estimates for the size of the universe place it at 150 billion light-years across, although it appears to be strangely inconsistent with the age of the universe, which you'll learn about next. This value is easily understood when you consider that the universe is expanding at an accelerated rate. It will become cold as it ages. Observations of galaxies farthest from us show that the universe is expanding at a faster rate. This, combined with data indicating that the universe is cooling, leads us to believe that the most likely end for our universe is a big freeze. That is, there will be no usable heat. The big freeze is also known as the heat death because of this prediction. Accurate measurements of the current geometry and density of the universe by the Wilkinson Microwave Anisotropy Probe, WMAP, support such an ending. It was hot when it was young. The Big Bang Theory is the most widely accepted cosmological model since the discovery of cosmic microwave background radiation, or CMBR. Although no one knows what bang, we know from extrapolation that the universe was infinitely hot at birth, cooling as it expanded. In fact, scientists predict that its temperature was around 1 billion Kelvin within minutes of expansion. Back 1 second ago, it was said to be 10 billion Kelvin. In comparison, the average temperature of today's universe is only 2.725 Kelvin. In order to gain a better understanding of it, we must investigate structures smaller than the atom. Since cosmologists began to trace events backward in time using the Big Bang model, their views, which focus solely on the very large, have shrunk. They knew that extrapolating backward would lead them into a universe that was extremely hot, dense, tiny, and governed by extremely high energies. 95% of the universe is unobservable. Everything science has been studying for the past 350 years is but a minor contaminant of the universe, according to a discovery that has yet to sink into the consciousness of most working scientists. Atoms make up only about 4.9% of the universe's mass energy, the stuff you, me, stars, and galaxies are made of, and of that, only half has been spotted with telescopes. About 26.8% of cosmic mass energy is invisible dark matter, which is revealed by its gravitational pull on the visible stop. Dark matter candidates include previously unknown subatomic particles and black holes created during the Big Bang. However, in addition to dark matter, there is dark energy, which accounts for 68.3% of the universe's mass energy. It is invisible, fills all of space, and hastens cosmic expansion. And our best theory, quantum theory, overestimates its energy density by a factor of 1 followed by 120 zeros. Universe's large-scale structures. The universe comprises filaments, voids, superclusters, galaxy groups, and clusters when only the largest structures are considered. Superclusters are formed by combining galaxy groups and clusters. Some superclusters, in turn, form walls, which are also filaments. The vast empty spaces are referred to as voids. The fact that the universe is clumped together in some places and empty in others is consistent with CMBR measurements that show slight temperature variations during its early stages of development. The temperature throughout the universe is the same. The cosmic microwave background, heat left over from the Big Bang, was seen by the Planck telescope when the universe was only 380,000 years old. It depicts minute temperature fluctuations that correspond to denser regions, the seeds that would grow into today's stars and galaxies. The universe contained the heat of the Big Bang fireball. Because it had nowhere to go, it is still with us today. It is strange that its temperature is essentially the same everywhere, 2.725 degrees Celsius above absolute zero, minus 270 degrees Celsius, the lowest temperature possible. However, we imagine cosmic expansion as a backward movie. In that case, we can see that parts of the universe that are now on opposite sides of the sky were not in contact when the fireball of radiation broke free of matter. In other words, since the beginning of time, there has yet to be enough time for heat to travel between them and the temperature to equalize. Astronomers fixed this by claiming that the universe was much smaller than expected early on, allowing heat to spread easily. The universe has an age of 13.7 billion years. If you think that's incredible, consider the fact that we know it with greater than 1% accuracy. Measurements of the abundances of certain radioactive nuclei are among the older methods that have helped to confirm this value. In addition, observations on globular clusters containing the oldest stars have also revealed similar values. There is a supermassive black hole at the heart of every galaxy. Active galaxies frequently emit 100 times more light than a typical galaxy. With the discovery of quasars in 1963, it became clear that light does not come from stars, but from a central region smaller than the solar system. Matter heated to incandescence as it swirls down onto a giant black hole up to 50 billion times the mass of the Sun is the only conceivable energy source. NASA's Hubble Space Telescope discovered in the 1990s that while active galaxies account for only about 1% of galaxies, supermassive black holes are not an anomaly. Almost every galaxy, including our own, has one, but most have gone dark due to a lack of food. What are supermassive black holes doing in galaxies' cores? Were they the seeds from which galaxies grew, or were they created by newly formed galaxies? These are some of the most important unanswered questions in astrophysics. The universe was created. The universe did not exist indefinitely. It was conceived. All matter, energy, space, and even time erupted in a massive fireball known as the Big Bang 13.82 billion years ago. The fireball began to expand, and out of the cooling debris formed galaxies, vast islands of stars, of which our Milky Way is one of an estimated 2 trillion. In a nutshell, this is the Big Bang Theory. Whatever way you look at it, the idea that the universe arose from nothing, that there was a day without a yesterday, is completely insane, but the evidence suggests otherwise. The obvious question is, what happened before the Big Bang? The unwillingness to confront this awkward question is why most scientists had to be dragged kicking and screaming to accept the Big Bang Theory. Let us know your views in the comments below and subscribe for more.